All right, so then you'll factor the GCF out of each group. We can factor GCF, right, out of each group. What you'll find is whatever's left over in your parentheses, it should be the same in both, at least for now, because that's the section we're on. Later in this chapter, it won't, and then you'll have another option. But as of right now, it will be, okay? And then you'll be, so when you go to factor, you'll take that common one and pull it out, and then your other parenthesis will be whatever's left over. And I'll show you. This is really not too bad. All right, so again, on your factor flowcharts, we've done this one, we've done this one. Today, we're going to focus on here. Here's all your steps, factor GCF, common parentheses, what's left, and it goes into that form. We will also talk about this crazy one up here today, too. Okay? Soap. All right, so 4 terms. Always with factoring, you set them equal to 0 first, which it already is. So we're going to group the first 2 and group, I want to include my sign in there. Group the last 2. So factor by grouping is actually very well named. What's the GCF in the first set? X squared. Let's take out an x squared. What's left? What's your GCF in the second one? What's left? What did I just say about those parentheses? They should be the same. So really, a lot of students struggle visualizing what the next step is. What you're doing is factoring out the GCF again, technically. What's common to your entire problem? X plus 1. So it's like I'm taking out the common factor of x plus 1. And if I take that out, what's left? X squared minus 3. Factored. If it was what? Say that again. No. All right, Alex's question, if they're like different, do I write them all down? No. If they're different, you can't do it. Or you did something wrong, one or the other. You may have learned this before. We've not learned it here, but you may have learned it in Algebra 1. Bless you. Yeah, there could have been on there. Yeah. All right, so then we just solve like normal. X equals -1. Good. This one, again, might need to do a little work here. So x squared equals 3, square root, plus or minus radical 3. If you can do that in your head, kudos. Yes, sir. Wait, on number 26, you hadn't learned how to do 4 terms yet. Last night on your homework, you mean? I hadn't taught you how to do 4 terms yet. So it would have been hard because you didn't know how. Now would it be hard? No. What? Oh, no. If you figured it out on your own, kudos for you. Most people don't. What about number 12? What do you have to do first? Good. Set equal to 0. All right, so after we set it equal to 0, notice, hey, I have 4 terms. Okay, so we'll have to group the first 2, group the last 2. GCF in the first set. What's left? GCF in the second set. -1. What's wrong? No. First thing we did was set this equal to 0, so I had to subtract these over. There it is. Yeah, anytime you're factoring, it's always set equal to 0. All right, so we took out GCF of the first one, GCF of the second one. No, they're not always x plus 1. It's just a fluke that happened on 2 problems in a row. So what's your common factor to both? Well, the common factor, there you go. Order doesn't matter, but that was just the question I asked. Good. So if I take out my common factor, I'm left with 4x squared minus 1. So there it is factored, taking out GCFs. Set each one equal to 0 and solve. So x equals negative 1. It's the easy one. Very nice. I'll show the work for those who can't do all that in their head. Did you do it in your head or did you just work ahead? A little bit of both. Okay. So let's add 1. Divide by 4. So x squared equals 1/4. Square root top, bottom. So plus or minus 1/2. How many answers were you supposed to have? 3. How many answers do you have? 3. It's good to do that little check, because as this chapter goes on, you're going to have a lot of answers. We want to make sure we don't lose some of them. Right? You guys want to try one on your own? All right. Try number 13. All right. 13, first thing, set it equal to 0. Went ahead and did that. Group the first two. Group the last two. GCF in the first set. What's left? GCF here. What's left? Common factor. What's left? I don't know what I was going to write. No, I just wasn't making my 9. I don't know what I was writing. So solving, we get x equals negative 1/2, and x equals, that's it. Oh, yeah, don't do that. All right, questions? What? Did you get 2x plus 1? So 2x plus 1 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. There's no x squared. Did you have an x squared? Yeah, we don't have one. Yeah, if that was 2x squared, then we'd have to deal with that, but we don't have that. All right, how about 14? You don't have room for that? It's already equal to 0, so let's group the first two, group the last two. GCF in the first set? What's left? GCF? A positive 5. I'm still going to write the plus sign. That way I remember what goes into my parentheses down here. So x plus 2. Common parenthesis. Left over. X equals negative 2. This one may have to write down. Good. So x squared equals negative 5. X equals plus or minus I radical 5. So how are we feeling about factor by grouping? What happens when you go to group something and there's nothing common to pull out for a GCF? Whoa, okay, let's talk about something. Yeah, let's talk about that. Let's say, I'm not going to do the whole problem because I'm making this up on the fly. But let's say you're working through a problem, you get 2x plus, 2x cubed. It's hard to make them up on the fly. Plus 4x squared plus x plus 2. Yeah, that'll work. Equals 0. That should work. So if I get that, let's say you're doing your grouping. What comes out of the first set? Left with x plus 2. Common factor there? I need to take out something. 1. X plus 2. That way when you take out that common factor of x plus 2, you don't forget you need something there. Because your other one then will be 2x squared plus 1. Okay, do we see that? So if there is no GCF, please take out a 1, just so you have that term there so that you remember it there. Okay? All right. We're bypassed that. Here we go. Next day. There we go. Let's talk about cubes. We've done squared things forever. Let's talk cubes. What's 1 cubed? 1. Let's make this list. This list is very handy in the future. 2 cubed? 3 cubed? 4 cubed? That's 64. 5 cubed? 125. 6 cubed? What did you say? That is 216. 7 cubed? Obviously, we can put them in a calculator. Some of you know these, which is awesome. 8 cubed? 9 cubed? 10 cubed? That is 1,000. That was Seth who screamed 1,000, not Anthony. You screamed 1,000. He thought it was Anthony. I said it was Seth who said that. All right. Guys, we are talking about perfect cubes. The faster you learn this list and can recognize them, the better. Are you required to memorize them? No, you have a calculator in front of you. Yes, that's chapter 6. Yeah. Yep. We'll talk about that in chapter 6. All right, but if you can start, when you see these numbers, to recognize, oh, those are cubes, that'll help you out a lot, okay? So reference your list, got it? Got that? All right, let's talk about the new way of factoring. This is the last method of factoring we will learn this semester, okay? Yes, this semester in my class is the last type of factoring you will learn. Oh, I like factoring. Thank you. All right, the new pattern is sum and difference of cubes. Now, we have difference of squares already, right? Where you had 2 terms, and you could take the square root of both numbers. So now, we're going to have sum and difference of cubes. So for the cubes, it can have a plus or a minus in between there, and it doesn't matter. Difference of squares had to be a minus. Cubes can be plus or minus. Okay? So here's how this goes. You have to memorize the pattern. And it's not terrible. Once you kind of use it a couple times, it starts to, you start to see it. It's not too bad. All right, so how this works, so if I have a cubed plus b cubed, or a cubed minus b cubed, right? We're going to set these up by the first parenthesis. You take the cubed root of both of these. So what's the cubed root of x cubed? X, you'll see that a lot. And then your other cubed roots, you can either use your calculator or you have a list right here. Do you guys know how to do the cubed root on your calculators? That's cubit. Real quick, let's make sure we know how to use the calculators in front of you. No, hold on. You have to hit 3. Hit the button that says 3. Then you hit the second button. It is above the caret, thank you. And then the caret. Because above the caret, it shows the square root, and then it's got an X right there. Hold on. That one, you hit the math button? Oh, yeah, math has a cube root. Math is on there. Has cube root. Yeah. All right, so if you, the regular scientific calculators, you have to hit the 3 to tell it you want the cubed root. Then you hit the second caret because it brings up the little square root with the little x here. That's you telling it I want a 3 right here, cubed root. If you have the graphing calculators, hit the math button. That actually shows cubed root on there. You can just choose it. Okay. Okay, so here we go. So let's talk about this pattern. So you take the cubed root of both of these numbers. That goes in the first set. And then the second set of parentheses, you will square the first number. So once you get to here, I don't even care about this anymore. You're going to square the first one here. And then AB, you're going to multiply the 2 of them together, put here. And then you're going to square that last number at the end. So square, multiply, square. You have to memorize this. we'll do this a lot. You'll start to recognize the pattern, okay? The SOAP is how I remember what the signs are that go inside of here. Okay, SOAP is same, opposite, always positive. So if you look inside here, since this, I erased it, hold on. Since that was a plus to begin with, my first sign is the same as this one, plus. And then I did the opposite, and this one's always positive. So if I look here, this was a minus in between here. I use the same sign, opposite, always positive. So me personally, when I set these up, the first thing I do is I set up my parentheses and I fill in my signs. And then I go back and we'll talk numbers. Okay? Let's look through some of these, okay? So here it is right here. Take the cubed root to get these numbers, square, multiply, square. That's how we get our numbers. So let's look at the example. So I'm not even worried about solving right now, okay? Let's just talk about how to factor it. So I'm going to recognize I have two terms. It has to be two terms. Is 27x cubed a perfect cube? Is 8 a perfect cube? Yes. So I know I can do this. Set up my parentheses. That second parenthesis is a little longer because it's going to have 3 terms in it. And remember to always use SOAP because it's disgusting if you don't, especially when you don't use your toilet paper there, Jesse. Right? All right, so same, minus sign, opposite, and always positive. So I know my signs right away. Fill them in. Questions on the signs for there. Same, opposite, always positive. Next, we're going to fill in the numbers. We're going to take the cubed root to get our numbers that go in the first part. What's the cubed root of 27x cubed? 3x. Don't forget your x. Cubed root of 8. Questions there. Just like difference of squares, we always took the square root of our numbers. These are difference of cubes. We're going to take the cubed root of our numbers. But then we got to fill in this. It's always square, multiply, square. So what is 3x squared? 9x squared. Then we're going to multiply. What's 3x times 2? And I don't care about signs because I already filled in what sign it's supposed to be. And then what's 2 squared? I just factored. It will never factor any further, ever. I just factored. Isn't that beautiful? That's how you factor. Yep. It's really a matter of can you memorize how it factors. Paige? Because I'm squaring this number first. No, it's 9x squared. Because what's 3x times 3x? X squared. Remember, to square something means to multiply it by itself. So 3x times 3x gives me 9x squared. When I'm squaring here, what's 2 times 2? It's just 4. There's no x on it. Alex? Definitely not a GCF. Think of it. Oh, I see what you're going with that. Kind of. Yes. Michaela? We took the cubed root of both of these. Cubed root, cubed root. And if you have your list, I had 8, the cubed root is 2. We added 27 on there, right? The cubed root is 3. I can work that backwards. Yeah. Oh, you're right. It shouldn't be. Look at you guys. That's what you're focusing on right now? Moving on. Listen to you guys. I'm trying to help you remember things, all right? Trying to be nice. All right, guys. It is on your flow chart. Now you know everything on your factoring flow chart. Ta-da! All right, so let's practice some of these cubes stuff. Number 14, x cubed plus 27 equals 0. Can I do this with a plus sign? Yes. Remember, squares has to be a minus, but cubes can be plus or minus, doesn't matter. All right, so let's set it up. I would go ahead and put your signs in first. So same, opposite, always positive. Good? All right, what numbers go in here? What's the cubed root of x cubed? Cubed root of 27 is 3. Taking the cubed root. After I do that, do I even really look at the original problem? No, I'm done looking at it. Because then this is going to be square multiply square. I'm looking here. Sorry, it's like square multiply square as I'm working through. So what's x squared? Multiply, what's 3 times x? And square, 3 squared? 9. Look at that, you factored. Ta-da! But we need to solve. 3? Yeah, which is why we don't care about the signs. Yeah, fill those in first. We don't have to worry about it. All right, guys, that is factored, but we do need to solve this. So we know that x equals -3. You could complete the square if you so chose. All right, what did I tell you about this? Will this factor? No, it never will factor further. Ever, ever, ever. We have to use quadratic formula. So x equals -b, 3 plus or minus square root b squared minus 4 times a times c all over 2 times a. That quadratic formula, man, that just keeps coming back and back and back again. Now, at least that's factoring, but this wants us to actually solve. So we get x equals 3 plus or minus, what'd you get under there? -27 all over 2. Let's clean up that radical -27. 3i radical 3. Very nice. And can I simplify any further? Nope. So I am done. So we have a new method of factoring. It's a pattern you have to memorize. I mean, it's just the way it is. I don't think you're going to do a guess and check and figure that out. You want to memorize that pattern. All right, and then once you do that, the quadratic part will not factor further, so you're going to have to use quadratic formula every time. Square multiply square? Question? Square, multiply, square. Square this, multiply these two together, and then square that one. And we already filled in the signs right from the start, so we don't have to worry about what the signs are. Yes. Here we go. 17. That's what happens if you go to the bathroom during class. 17. It's already set equal to 0. We have two terms. Recognize they're cubes, right? It's an x cubed. Is 8x cubed perfect? Is 1 a perfect cube? Yes. Okay, so let's set up our parentheses. Let's fill in our signs. Remember, that's SOAP. So same, opposite, always positive. We take the cubed root of 8x cubed, cubed root of 1, 1. So at that point, I don't care about the original problem, right? And then we do square, multiply, square. And we're using these numbers, right? So we're going to square 2x. So what's 2x times 2x? 4x squared. And then you multiply the two numbers together, 2x times 1. And then you will square the last one. Yes, very weird. All right, so then we know x equals, the first one gives us -half. How do we have to solve the other one? quadratic formula. So x equals negative b, so make 2. So negative 2 squared minus 4 times 4 times 1 all over 2 times 4. All right, what do we get underneath the radical? All over 8. So how do you simplify radical negative 12? 2 plus or minus 2i radical 3 all over 8. All three numbers can be divided by 2. So x equals 1 plus or minus I radical 3 all over 4.
Are you sure you want to try to fit that rest of it?
Barely fit. I wrote too big. All right. Feel a little better? 18 is very important that we talk about. What's the first thing you have to do with it? Set equal to 0. Let's look at that first.
GCF.
Alex, what did you just say? Yes. The way it sits, is 54 and 16 a perfect cube? No, but what's the GCF? 2.
So good.
That's my advanced class right there. Nice job, guys. All right, 2. So 2 x cubed. That's why I was like cubed. 27x cubed minus 8. Now are they perfect cubes? Yes, they are.
Can we just leave it?
Well, he's still my baby brother. Jesse? Stay tuned for later in chapter 5. Still in chapter 5. Yeah. All right, so for my sign, same, opposite, always positive. All right, cubed root of 27x cubed. Cubed root 2. Square, multiply, square. 3x squared. 9x squared. Multiply. Square. Good. So we know x equals 2/3, positive 2/3. And then we have to use quadratic formula over here. I know. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. What do we get underneath that radical? Negative what? Want to wait? Thank you. All over 18. So that should give me 6i radical 3 over 18. Sure, you trust me, right? Take my word for that. All right, you can divide them all by 6. So we get negative 1 plus or minus I radical 3 all over 3. How many answers am I supposed to have? How many answers do you have? 3. Good. No. Good question. Question was, does this give you an answer of 0? Do you have an x? No. If there was an x out there, yes, it would. But since there's no x.
Wait, so we don't need to put x.
This,
Oh,
if I set it equal to 0, did it give you an answer for x? No. All right. I have more examples. Are you good? We're good? Okay.